property triangle inequality. What is it? Triangle inequality. Okay, now the statement of the theorem is the statement of the theorem. What is the statement means? For any two complex numbers, for any two complex numbers, for any two complex numbers z1 and z2, we have, for any two complex number z1 and z2, we have modulus of z1 plus z2, which is less than or equal to modulus of z1 plus modulus of z2. What is triangle inequality? Modulus of z1 plus z2, which is less than or equal to modulus of z1 plus modulus of z2. So to prove that this result. Next, see the proof. So what is given? Left hand side, modulus of z1 plus z2, modulus of z1 plus z2, which is equal to, before that we need only the result modulus of z1 plus z2 means modulus of z1 plus modulus of z. We know that the result. There is no simplified terms. So taking left hand side, squares modulus of z1 plus z2 the whole square, which is equal to, we know that the result, what is it? Z bar means we can write it as modulus of z squared. What is the result? Z bar means we can write it as modulus of z squared. Modulus of z squared. So, which is in the form of modulus of z squared. Modulus of z squared means we can write as z bar. Here z is z1 plus z2. Here z is z1 plus z2. Now write it here. Z into z bar. Z is z1 plus z2 into z bar is z1 plus z2 the whole bar. Okay. Next, which is equal to, again we know that the result or property z1 plus z2 the whole bar, we can write it as z1 bar plus z2 bar. Z1 bar plus z2 bar. Write it here, z1 plus z2 into z1 bar plus z2 bar, which is equal to z1 into z1 bar plus z1 into z2 bar plus z2 into z1 bar plus z2 into z2 bar, z2 into z2 bar. We know that another one result, z double bar values z. Before that we rearrange these two terms. See, z1 into z1 bar, z1 into z1 bar, write it as usually, plus this term z1 z2 bar, write it as usual. Consider this term only main thing, listen that carefully. Here z2 z1 bar, we can write it as z1 z2 bar the whole bar. What is it? z1 z2 bar the whole bar. Listen. Consider this, z1 z2 bar the whole bar. So take it separate bar. So z1 bar into, here take it bar, z2 bar, already one bar, and take it another bar. So z1 bar, z double bar values z only. So here z is z2. Then only we use the result z double bar is z here. Z double bar is z. Now, these two terms like similar terms, z1, z2 bar, z1, z2 bar. Am I right? So it can be written as these two terms, real of z, that is 2 into real of z, 2 into real of z, because of the result. See, modulus of here z1 bar, we can write it as z squared, because of z bar means we can write it as modulus of z squared. So here z place z1 occur. So z1 z1 bar means we can write it as modulus of z1 square. So modulus of z1 square. Got you understand, ma? Plus these two terms, write it as 2 into real of z1 z2 bar, plus z2 bar can be written as modulus of z2 square. Why here we write it as 2 into real of z1 z2 bar means we know the result, 2 into real of z is equal to z plus z bar, z plus z bar. So here z location z1 z2 bar, z location z1 z2 bar occur, plus z bar location here occur z1 z2 bar, the whole bar, z bar form it. So we can write it as 2 into real of z1 z2 bar. Now, which is less than or equal to, first term write it as usually modulus of z1 square plus 2 into modulus of z1 z2 bar, modulus of z1 z2 bar. 2 into real of z1 z2 bar we can write as 2 into modulus of z1 z2 bar. Inside the bracket terms as usual, real only leave it, because see the property here, real of z which is less than or equal to modulus z, real of z which is less than or equal to modulus of z. So here real of z occur, am I right? So leave it this, we can write as modulus. Okay, so what is the property? Since real of z which is less than or equal to modulus of z, so z location z1 z2 bar occur, so modulus of z1 z2 bar plus modulus of z2 square, which is equal to, here only we write it less than, don't forget it Rakana, all the guys do this mistake only in this theorem. Okay, so here only less than or equal to occur, and after that we use equal only, like here. So equal modulus of z1 square plus 2 into, write it separate modulus z1 into modulus z2 bar. Okay, plus modulus z2 square. Here use the result. Which results here used? Modulus of z1 into z2. We can write it as modulus of z1 into modulus of z2. Next see, which is in the form of a square plus b square plus 2ab. So what is left hand side? Modulus of z1 plus z2 the whole square. When we write the left hand side, that time we use the less than or equal. Otherwise we write it equal. Okay, these two steps write it carefully Dakana. So less than or equal to modulus of, which is in the form of a plus b the whole square. So modulus of z1 plus modulus of z2 the whole square. Modulus of z1 z2 the whole square. Now taking positive square on both sides. Taking positive square on both sides. Taking positive squares on both sides. We get square get cancel. Okay. So modulus of z1 plus z2 the z2 which is less than or equal to modulus of z1 plus modulus of z2. Here square root. Taking positive square root on both sides. Taking square root cancel. Square root 2 cancel. And then modulus of Z1 plus Z2, which is less than or equal to modulus of Z1 plus modulus of Z2. Hence the theorem proved. Hence the property proved. Okay, got you understand, ma'am? Read it once again.